Once again, I'm Chessley Atchison. I actually was lucky enough to grow up in the city and a farm. I grew up in a farm raising cows and peanuts in Gorman, Texas. Went to high school on the west side of Fort Worth at Western Hills High School. After that, I went to Tarleton State University. All I ever wanted to be was a cow doctor when I was growing up. And I got to go to veterinary medical school, and after 2 years in private practice, I was sewing up a sick cow one day. It was about 7 degrees and the snow was drifting around my ankles, and I said, there's got to be a better way to make a living than this. And at that point, the Army, at that time I'd worked 363 days out of 365 days in large animal practice. And so when the Army said I could have 30 days off a year, I said, I will be glad to join your lovely service. And so with that, I joined the United States Army. My first 2 assignments were incredible assignments. I was at Davis-Monthan Air Force Base. I took care of military working dogs. Life was fair. I thought everybody was supposed to have that wonderful a life. I saved a general's dog. Next thing you know, I had my own parking place at the officers club and the golf course. Then my next assignment was 1st Armored Division, Bad Kreuznach, Germany, where I served as a division veterinary surgeon. During that time, I helped write the medical op plan for the Bosnia-Herzegovina operations. And so I've had quite a varied career. At that point, I was lucky enough to be selected for long-term continuing health and education. And at that point, I got to go to the University of Texas Medical Branch in Galveston, and it was a very unique program. Experimental pathology in the pathology department was divided into 2 tracks. Half of it was infectious disease, and the other half was toxicology. Our first year, we were all together as students, so it's both infectious disease and toxicology. And so some of the best doctors in those fields I was able to be exposed to, and I had incredible professors. One of my professors, Dr. Wayne Snodgrass, was the first person to get a clinical trial approved in pregnant women for a drug since 1959 while I was working with him. And that's incredible capability. Dr. Brian West had been a chair at Yale Pathology and was chair of surgical pathology. He was the one that helped teach me to read slides as fast as you possibly could without throwing up on a microscope, because when those things are zipping around, it's just like, oh, okay, that's not good. But anyway, was lucky enough to do my dissertation research on diclofenac, Voltaren. It's a non-steroidal anti-inflammatory drug, and so I did basically drug safety research for my dissertation. So after that, I went to the Institute of Chemical Defense, and I started doing low-level chronic exposures to chemical warfare agents to start developing occupational health models and safety models and trying to develop ways to predict injury associated with low-level exposures. High-level exposure has been known for many years, but nobody had really known about the chronic effects. So after that, I then went to MRMC headquarters to be a staff officer, and we have a thing in the Army called the POM. And for those of you that know what it is, that's the long-range budget. Well, I didn't know what I was doing, honestly. And when I got there, they said each day they would bring me slides, and all of a sudden, after 6 months, they said, well, you need to go downtown. Well, I still didn't know what I was doing. I knew what I was reading, and I knew what I was telling them, but I didn't know I was building about a $1.4 billion budget a year for the next 5 years. And after I'd done it once, they go, well, that was a good job. Are you going to do it again? I went, do what? And that's when the point I found out that, oh, that's what I just did. So if I'd known what I was doing the first time I did it, it would have scared me to death. After that, I was lucky enough to be selected for command. But before I went to command, I did a year at the Surgeon General's office. At the 1 year that I was there, for those of you who remember the melamine poisoning in the cat food and dog food, and in certain countries in baby formulas, well, I was the food safety officer at the Surgeon General. So when it came time, I was the lead for the entire Army for the melamine poisoning. Luckily, my PhD in toxicology came in really handy because I could answer those trick questions that they were asking. So I got to do a little time at the White House and on the Hill and other places. After that, after my time, then I went to command at Chipham North. It's now a public health command. And so at that time, I had the responsibility for all Army installations over 21 states at that time. I had the leishmaniasis program for all those places. I had West Nile virus program for all those areas. Had incredibly talented young officers, PhDs, masters, entomologists. We did all kinds of incredible research. We had some occupational health. We had engineers. It covered the gambit, so we did a lot of interesting things. After that, I did 2 years at the Defense Threat Reduction Agency. At the Defense Threat Reduction Agency, I was a science and technology lead for global biosurveillance early warning. And some of the things that we were looking at was early disease outbreaks in Africa and how it might affect the United States. You may have heard of some things recently. I got to visit a lot of those places in Africa when I was doing that research. And after that time, I came back to medical research and material command. Well, when I got to MRMC, I was going to just be a portfolio manager and manage a basic research projects. I'd been there 2 weeks when Dr. Glenn, who was our principal assistant for research and technology, called me and said, I need you to come see me. And I went to his office at noon, and he said, I need you to help with what's going to be called the Technology-Enabled Capability Demonstration. Now it's called the Science and Technology Objectives. The Army changes the names of things every so many years to keep people fresh. But what the Technology-Enabled Capability Demonstration was to take things from out of the basic research realm and put it into advanced development. It's called this Valley of Death in all branches of acquisition, be it a tank or be it drugs or be it a device or be it a weapon system or whatever. It also exists in regular industry, because how do you get things from that bench top all the way to use? And so what they wanted me to do was look at what things I could do with traumatic brain injury that was in the basic research realm and deliver it to the warfighter. But let's make it a little harder. Everything that we use, everything we give the soldier has to be FDA approved. We do not give anything to the soldier that's not FDA approved. Not only did they want me to do that, they wanted me to take some of these medical devices, make them non-medical, and give them to sergeants and platoon leaders and other leaders so they could take a look at their soldiers and make some decisions that would help when they needed to go to the medic and not go to the medic. At this time, we proposed the Vice Chief of Staff of the Army, General Corelli at the time, just traumatic brain injury. After he yelled at me and my boss for about 20 minutes, he said, you're also going to do PTSD, because I've been there, I've seen that, I've seen what happened to my soldiers, and I care. So the next question you should ask is why a guy this old is still in uniform, okay? I actually have 26 years active duty. But while I was in command at that laboratory at Fort Meade, the chief veterinary officer, a young lady by the name of Captain Mariah Kachavi, was the chief veterinary officer there. She wanted to follow in my footsteps, and she was very interested in my degree in experimental pathology and thought that would be a cool thing to do. And we became fairly close. Well, Mariah suffered a traumatic brain injury. And it was very, very hard on her. Mariah was a very accomplished ballet artist. She was a very accomplished veterinarian. She was an accomplished poet. She'd actually done some graphics for some medical articles in magazines. Well, Mariah got PTSD after traumatic brain injury. And on December 24th, 2009, she committed suicide. And this young lady was very important to me, and it was very hard. So when they asked me would I do PTSD and TBI, I said absolutely. My oldest son graduated from West Point in 2010. He graduated from USU's last year. He's at Fort Bliss now. He got orders last night to Fort Hood, and his orders to go to flight surgery school. So I've got skin in the game. I still got people that I care about doing this and doing it very much. So let me talk about this crazy thing and how I got there, and it was not my intention to do this. So I'm going to talk about environmental sensors and training, which is what's taking up a lot of part of my time now, but then I'll talk about the science and technology objective, brain in combat. Now, I'm going to bore you for a minute. We're not going to get in all the weeds over there, but 85.2% of TBIs are diagnosed in garrison. 20-something% are what actually happen in combat. It may be a little bit more, but the vast majority of these things happen in regular duty station. Now, not all of those are training, okay? There's motor vehicle accidents. There's combat basketball. You've got all the things. These are active soldiers that want to play sports. They want to do the things, the fun things that young people do, things I like to do when I was young that I can't do anymore because I'm not young anymore. And then 82% of those TBIs are mild concussion. This shows basically the number of traumatic brain injuries since 2000, and you can see the incredible numbers there. 183,000 in the Army, 42,000 in the Air Force, 45,000 in the Marine Corps, 42,000, a total of 313,816 injuries. This is the signature injury of this long war. This is a breakdown by, and I won't bore you with the details, but what you want to see here is where are the injuries occurring? And the reason this is important to me is that's why I'm doing environmental sensors and training. Where the soldiers are getting hurt is where they're doing the really hard things. So if you look here at Fort Bragg is the home of the 82nd Airborne. The 82nd Airborne jumps out of airplanes for a living, and one of their skill sets that they're required to do is to capture airfields. So when you capture an airfield, it has the consistency of this floor that we're standing on tonight. Well, the problem is with proper parachute landing fall, the PLF, when you land, you're supposed to have 5 points. But the problem is, if the wind's just right and you land, you don't hit with your feet, the parachute will make their head slap against the tarmac and knock them out. So that's the reason I have a major study going to be at Fort Bragg. Originally, and to back up just a little bit, so I go back to what I told you my day job was, PTSD and TBI. Dr. Glenn is my boss, and we've worked together for many, many years. And early on, when we talked about wanting to do this research, we designed a little bitty experiment. Okay, bear with me. A little bitty experiment. We were going to look at airborne soldiers and combatives. When soldiers do combatives and they learn to do hand-to-hand combat, they do take blows to the head. And so we were looking at what kind of available sensors we could use to put on the soldier's head to measure the effects and the acceleration, deceleration that they received when they took a blow. But also, when deployed in theater, we have multiple sensors that have been deployed to sensors. Blast over pressure. Those sensors were developed by DARPA. But there's also a thing called the helmet sensor. It's a sensor that's glued inside the helmet, in the crown of their helmet. So Dr. Glenn and I looked at, well, all we were really at the time were concerned about was, well, we want to look at airborne and combatives. So we're going to look at the helmet sensor and one of the NFL sensors that glues behind the ear in airborne, and in combatives, we were just going to use the sensor that glued behind the ear. So how are we going to do this? Well, they don't let nerd scientists just show up at Fort Benning and say, can I have 12 of your soldiers? I'd like to pull them out today and put sensors on them. The commanders get really excited when you say things like that to them, and they usually chase you off the post. So Dr. Glenn and I went down to Fort Benning, Georgia, and we said, we have this effort, and it's a science and technology objective. And we want to do these things, and they're medical technologies, but we have to do it in a relevant environment. And the Maneuver Center of Excellence at Fort Benning, Georgia, it used to be just the infantry school. It's now the Infantry and Armor School, has the Maneuver Battle Lab. They test technologies. They give technologies to soldiers and see if they can break it. Can they use it? Is it the right color? Should it be green? Should it be pink? What color should it be? Does it fit in their hand? And so that's their expertise. I'm a nerd scientist, but that's what these guys do. So I went to them to ask them to help me do my work. And so we asked them about that, and then we briefed that one little bitty experiment to them. They said, that's really cool. We like that. And so their general briefed his general, and his general briefed his general, and his general briefed his general, and then his general briefed his general, then his general briefed our general, and that general briefed this. When he came back down, I was invited to go to TRADOC at Fort Eustis, Virginia. And they said, tell us about your experiment. And I told them. They said, well, that's awesome. Well, what are you going to do about blast? I said, well, we're just currently interested in acceleration. He goes, no, you're going to do blast. I went, okay. He goes, you're now the environmental sensor lead for the entire United States Army in training. And as I volunteered once, this is what's being called voluntold to do something. And so now all of a sudden I got this massive problem set that I've got to try to figure out how to deal with. So not only am I worried about airborne school, now I'm worried about combatives. Not only am I worried about combatives, I'm worried about artillery fire. Now I'm worried about shoulder-fired weapons. I'm worried about mortars. I'm worried about blowing up bridges. I'm worried about all these things. So I was a little nauseous, and I said, I think I got to step back about this and think about this a minute, and how am I going to approach these problems? So what we came up with, and now I'll get into this, was the ESID effort. There's a couple things you need to know about the Army. We buy equipment, but what I do as a medical officer, what we do is we have the skin in. So when you look at an environmental sensor, There's a program executive office and a big part of the Army that buys stuff for the soldiers. That is not me. But one of the things that we said we were going to do in our science and technology objective was concussion algorithms. And what a concussion algorithm is a measurement of an environmental occurrence, be it blast over pressure or an acceleration deceleration, and predicting the probability of injury from that level of energy absorbed or that has been exposed to. So that's a probability. That algorithm is a dose response curve of the probability of injury based on energy. This be either PSI or BGs of acceleration. So, but our purpose, my job is not to pick what the best sensor is. And I will tell you, since we started this effort, the world of sensors has exploded, okay? So what Dr. Glenn and I agreed to do was we would try to help describe what the technical requirements would be. How many PSI should it measure? How little PSI should it measure? How many Gs? Does it need to measure 200 Gs? Or does it need to measure 400 Gs? So that's one of the things that we agreed to. Now, my interest in it still was the same, to identify soldiers who need to be pulled out to be used for us to look at medically and be objective about who comes out of the line and goes to do work. Now, and we'll come back to this later. So I started out doing this, but now all of a sudden the Army has told me, in no uncertain terms, I am doing this. And so currently, the sensors that are deployed to theater, and I alluded to them, here's helmets, and you see them glued inside the helmet. And that's the BAE system, the Gen 2 system, and it's acceleration. It does have a blast pressure gauge, but the problem is it's inside the helmet. So when the blast pressure comes, it goes right over the helmet, it doesn't see it. But it did measure the acceleration, deceleration of the helmet. But there's a scientific problem there. It's measuring the helmet, but not the head. So the translational force between the head and the helmet is lost. Now the DARPA blast gauge, now B3 biometric B3 blast gauge, was a very good pressure gauge. And they put one here, and they put one here, and they put one here. And it was very good, but the problem is you would have a soldier receive an injury that would only send off one gauge, but none of the other gauges would go off. So there's a challenge. Though when they first deployed the blast gauge, I have to tell you, the soldiers called it the lucky charm. Because all the soldiers who were issued that the first year, not a single one of them was exposed to explosives. Darn the luck, okay? So now they went back, maybe we should give it to different people and make sure it's going to the right people. So we learn as we go. And I like to tell people this, the ingenuity of the American soldier is the greatest thing that there ever is. I'm a nerd scientist and I tried to help. But it's the soldiers 9 times out of the 10 that figure out how to fix some of these problems. So this is what TRADOC gave to me. TRADOC is the command in the United States Army that's responsible for all training. So they have the schoolhouses, they have the different things, how to be a truck driver, how to be an infantryman, how to be an artilleryman, how to do these different things. And this is what TRADOC gave me. They said, this is where we're worried about soldiers getting hurt. And so here we go, firing artillery. We're firing a shoulder-fired weapon. Okay, if you're standing right behind there, that's 36 PSI. That's a lethal blow right there if you're standing in the wrong place. Firing mortars from inside of a striker weapon. This is called breaching. Breaching is where they put a shape charge on a wall, then they stem back a few feet, and they hunker down, and when they blow a hole in the wall, they all run in with their weapons, and they kill the bad guys or capture the building. Okay? Well, what we've learned already from just the little research we did is how to do it smarter where we weren't injuring our soldiers who were blowing the walls up and going in. And here's the towers at Fort Benning, Georgia. This is the original Six Flags rides. If you've ever seen an amusement park where you see them come from the parachute and drop down, this is where it started because this is where it was invented. So we've had Six Flags at Fort Benning for many years already. And here's a bad guy. Notice he landed on his head and not on his feet. Here's combatives. And I met this guy. He's a very scary man. He's about this tall. He's about this wide. He has no neck. And he won the mixed martial arts 4 years in a row for the United States Army. They asked for a volunteer, and he pointed at me, and I was not happy. Vehicle accident rollovers, and that's been a big problem for many, many years in the military. Okay, so here's the sensor I was talking about that were glued behind the ear, right there. And so we could measure directly, and that was one of our first experiments, is we could measure the helmet, and then we could measure this and see what happens. Well, believe it or not, one of the funny things is if you take your finger and put it behind your ear and go like this, see how much that skin moves? What we found out one of our first experiments was if we had 2 of them, we could do the math and actually get the real number. And how we do that is they have, you know, like the things that women used to put wigs on and they decorate the wigs, so it's called a head form. We can actually put a real gauge in the center of that thing and do an actual scientific measurement that's extremely accurate. So when we looked at this one, and it has movable skin, we could tell how much the skin moved. We found out if we did 2, we could do the math and we could get the exact same number that the scientific gauge had inside. And that's the laboratory validation part of this. Our goals then were to answer a lot of the questions the Army had. And what they asked me, when they asked me the question formally, was what is the methodology? How do you use the sensor? Where do you use the sensor? Where do you wear the sensor? One of the next questions was which training lanes are dangerous? Which training lanes are not dangerous? So possibly learning how to be an Army communication specialist is probably not that dangerous. But however, if you're learning to fire heavy weapons, you're blowing stuff up, you're learning to fight hand to hand, there's a real good chance you're going to get popped in the head and possibly get an injury. So they wanted me to describe where they thought our best money was invested in training for the safety of the soldiers. And so, technical characteristics of the sensors, this is what we call requirements. The Army, when we buy things, I know you've heard all the horror stories about the $400 toilet seat, the $200 hammer. Where that comes from is we describe a set of requirements that a product must have. And the military for years has been ridiculous about how strict the specifications were. Those of you who are old enough to remember about the $400 toilet seat, guess how much airlines pay for the toilet seat? $400. It's the same specification. So there's a little exaggeration occasionally when people don't understand all the engineering behind it. Now medically, something came up. The Surgeon General's office called me and goes, well, this is interesting what you're doing. So this will affect medical policy and how we treat soldiers and how we do what we do with them. That's kind of like our problem. I went, yes, ma'am. Yes, it is. She goes, well, so you're going to fix this for me? Yes, ma'am. We will. And so now there's the medical aspect. And so my little study, if you're not starting to notice, is getting bigger and bigger and bigger and bigger. An example of civilian sensor technologies. You all heard, there's the HIT system right there. There's the X2. When we first started this, there's a thing you do before you go buy something. Many of you look at Consumer's Digest before you buy something. Well, when we do something that's kind of oblique and obtuse is what we do an analysis of alternatives or courses of action or a market analysis. And what that is what's available in the market. When we started this study, there were 7 of these available. Last week, one of the companies we work with, there are now 17 available. Now, if you're ever going to get research done, you have to draw a line and say, okay, that's it, that's last takers, stop. So we did the 7 that we had at the time, and we put them through the rigors of our studies. This sensor, as you see, is small there. From what I've heard, their last prototype is now about that big. And that's because the technology is growing so rapidly. They're making the accelerometers and gyrometers smaller and smaller and smaller. Here's the combatives. In this particular one, they're wearing headgear. They don't always wear headgear. It depends on what the drill is they're doing. If they're pretty sure they're going to get popped in the head, they have this. But they don't always wear the headgear, yet they sometimes still take a pretty good punch. I will impress you with this little thing. Where I grew up in Texas, you kind of had to learn how to fight or you were going to get your ass beat, pardon me. But I grew up with this kid, his name was Charlie Norris. I don't know what he's doing now, but I think he makes movies or something. But I remember watching him as a kid, and he was just so much faster than everybody else. It was just completely scary. And so here's some of the things we've done, airborne operations. Here's a funny little story. Okay, so before we give anything to a soldier, be it a canteen, be it a set of gloves, be it anything, it has to have a Army safety release. We give it to a bunch of testers to make sure it won't hurt the soldier. Well, there's another thing. If you're going to jump out of an airplane, you have to have a different safety release. And so the Airborne Special Operations Test Directorate at Fort Bragg is who you have to go to get all these different devices approved. So, true story. I send 3 of my PhDs to go to Fort Bragg. They're going to equip 40 soldiers with sensors, all the different types of sensors we got, everything we can get our hands on. And they go to Fort Bragg. They're going to be the third jump of the day. Test director. What they do, they push things out of airplanes and see what happens. The first pass of the day was a Humvee with a parachute. I know you've probably seen that on TV. They pushed it out, settled down, and they drove it off. So they're finishing getting their guys ready on the jump ramp, and then they go to sit down in the stands, and the next plane comes over, and it's a 4,000-pound forklift. They push it out, nothing happens, it goes straight in the ground like a lawn dart and disappears below the surface of the earth. Well, there's no more jumps that day because there's paperwork to be done. And so they didn't get to jump that day, but the people at Airborne Special Operations Test Directorate were very nice and called them and said, we'll get you another plane in 2 weeks, okay? But we're not doing it today. So my 3 PhDs, I said, so YouTube, you got YouTube for me. Where is it? And the 2 responses was, it was awesome. And the third one goes, it was a bit disturbing. Now, here is the typical load of your airborne trooper. He doesn't have much on him, okay? It's very light load. You don't see anything there to get in his way. This is the full combat load, and this is a standard jump, okay? So you've got your main parachute, you got your accessory parachute, and you've got your rucksack. So what could go wrong? I mean, it looks like a perfect setup to me. So there's now, before become a paratrooper, there's 3 weeks of training. There's ground training, there's tower training. So here's ground. They're learning to jump into a pit. They're 3 foot off the ground. This one, they're coming off in a swing device. So this right here, it used to be sawdust in the olden days. Now it's rocks. They actually found out that river gravel gives better because it slides, and so when they hit it, it disperses the energy and it doesn't hurt as much. And they did all this scientifically to prove that. The laboratory that I've been working with, USRL, did a lot of that original work to see about neck injuries and stuff. So those are rocks now that they're jumping into. So there's a week of doing this, and the black hats are the NCOs that teach. And they have that mountainous voice. We are going to do this now. We're going to, and they do it over and over again. That's how they get the soldiers to memorize how we're going to do that now. And every one of them does it. And they do it until it becomes habit so they don't freak, because they're going to jump out of a real airplane in a couple of weeks. And the best thing to prevent that is training. So a little story there, and like I said, this is unprecedented for them to let nerd scientists walk around in their schoolhouse. And in fact, I got to meet their brigade commander, and I got a pretty good introduction to a line, and I got some emotional discussion with him. But they let us go, and there was 2 young female second lieutenants that are in the line. We all know we're very gung-ho and everything. There's 2 young female, and they've been doing this. And when they get in line to practice jumping, they go like this, everywhere they go. And so there's these 2 young second lieutenants. And I went over to the black hat and said, can I talk to those 2? And he goes, sure, sir, you can talk to whoever. He called their roster candidate numbers out, and they ran up and reported roster candidate numbers. And I go, so how y'all feeling? The first female lieutenant goes, outstanding, sir. I'm so happy to be here. And I looked at the second one, how are you? She goes, I've slept in a bed of rocks for weeks, and I can barely move my head. And I turned back and looked at, you want to restate yours? She goes, I feel like her. This is important, though. The part of this training was, it was strengthening their neck. We now know in recent research that the strength of your neck is directly proportional to traumatic brain injury. So the stronger the neck is, the better it is. That first week is so important in strengthening their necks and getting them ready to do the proper PLF and to land. So each of these little things may look like they're very small, but they're very important. One of the things people used to always say is they wonder why they ran every morning. You see the airborne troopers run everywhere. It's not to see if they're physically fit. It's to figure out if anybody's injured and they have lied about whether they were hurt or not. And so if they can't run, then you go, you, come here, go in the clinic. Because these kids want their airborne wings. They want to succeed. And here's the parachute landing fall drill. And this is it. I mean, if you ever get a chance to just sit here and listen to this guy, and now I'll fall down, you know. And it's a lot of fun. Here's a swing land trainer. This is a device a fellow invented to where they can jump off and they control their fall, and then at a certain process, if they're trying to teach them to land at different angles so they can land from the front, the side, or backwards, they pull the rope at just the right time and they go in. And so this is how they teach them to land sideways, forwards, and backwards. And that's a swing land trainer. Static line jump, that's the T11 parachute right now. That's a new parachute. It's had decreased injuries. They went to a bigger parachute that had a slower rate of descent. Now there's something interesting. For those of you that have ever seen the diversity of the audience that's in the Army, we've got little bitty soldiers, and we got real big soldiers. Well, guess what? The big ones, when they jump out, they come down faster than the little bitty ones. And in fact, the first day I went to go out to Fort Benning to watch them jump, a few of the lighter ones would actually start floating off. I said, they are coming down, right? You know, and they go, yeah, they're coming down. But there's some of the heavier ones would just come down. And so what they've learned to do is to write the weights of the soldiers on their helmet so they make sure they put them on the right part of the plane so when they jump off, they don't hit each other or land on top of another one. Here you go, jump weight. Now, one of the things, what I'm saying, strap hangers here is we don't want to use the students for this part of the test. The reason is these kids are terrified. They're in at 4 o'clock in the morning, they're at the jump barn, putting their chutes on, doing the stuff, getting the stuff, but when you walk up and down the roads and you see those eyes, their eyes are all about this big because they're just going, I'm fixing to jump out of an airplane. What was I thinking? Why did I ask for this? What am I doing? So the strap hangers are guys that are stationed there that have to keep their jump status and jump pay. And so whenever they need to get in an extra jump, we can use them and they're experienced jumpers. So we use them and not the less experienced jumpers. Okay, this is one of my efforts right here to the tune of about $10 million. This is that mathematics I was talking about, the algorithm that determines the probability of injury. I was able to visit with one of the researchers from that group yesterday. Artillery pieces. I told you we were going to talk about blast over pressure. Every one of those guys has an assigned position and assigned place to be. We went out there, and what my guys did from Walter Reed Army Institute of Research, they're my blast over pressure guys. My acceleration deceleration guys at the United States Army Aeromedical Research Laboratory. They've done crashes and neck injuries and head injuries for years because they developed the aviation helmet. Little sidelight note there. When you think about aviation helmets in the Air Force, you know the cool jet jockey thing. They got the mask here, they got the hose here. You know, it's a really cool looking thing. Well, the Army aviation helmet is a styrofoam bucket. That's all it is. It's a little bit stronger than a bicycle helmet. The reason is all their avionics hang off their helmet. And if you used a helmet that was that heavy, it would hurt their necks. So they found out if they went to a helmet that was much lighter, they could hang off their sighting devices and all their other avionics and it not hurt their necks or their heads. So the aviation helmet. So these guys are the ones that did that. These guys are from right over here at rear. And so you look at these positions. And what we found was if you put a pressure gauge, a highly scientific pressure gauge, as well as the DARPA blast gauge, at each of those positions, you never saw it reach over a dangerous level or what's considered occupationally safe. However, if you're standing in the wrong place, say if the cadre is worried about something, he goes to check on something. The cadre is one of the trainers. He's one of the senior instructors that's teaching the soldiers what to do. If he's standing in the wrong place, it's not so good, okay? We did it all the way around. You can see the blast wave and then in front of there, we put gauges all the way around there. And there's several places, like I said, you do not want to stand when the round goes off. mortars, early on with the blast gauge. When you fire a mortar, it's a very simple task. You drop it in the tube, and when you drop it in the tube, you turn away, and you go like that. Well, we had a young soldier that decided he was going to watch. He dropped it in the tube and watched. Boom! And so we got a very nice reading on that, and he learned not to do that again. Here's some of the heavy weapons. This is one I was talking about. If you stand directly behind the Carl Gustav, for example, it's a recoilless rifle. It's basically a bazooka on steroids. When you see the old war movies and you see them fire the bazookas, okay, take that and multiply times 100. That's the way these things work. These are your anti-tank weapons. From talking to people with the Carl Gustav, even if you fire it themselves, it was developed by the Swedes. If you stand directly next to the tube, you're going to get a blast over pressure, say 4 to 5. And if you're right, so that's how the Swedes fired. We have one guy stand here to watch the other guy. Well, if you're standing right here, that's 12 psi, and that's starting to cause problems. And so those are the things that we're determining and we're finding when we do these studies. So the leading questions for the sensors, what are they? Performance, location, overpressure, form and fit, energy requirements, batteries. Everything takes batteries these days, everything. And so how long will the battery last? Do I need to recharge it? I got my new portable battery I bought for my phone this week. Do I need something like that? How can I charge? Well, how do I download that data? That data, if I do have data, and then it gets real complex, because if you look at blast overpressure, you've got this very complex wave, and then you get in the argument of scientific, well, is it the peak amplitude? Is it the rate of acceleration? Is it the average across the curve? And so then we get into some serious scientific discussion of what all data we need to capture. Acceleration, deceleration is the same thing. How quickly does that G-force occur? So we got data acquisition. How much data? We've overwhelmed soldiers with too much data. So what is really important? Sensors alert. Now here's a couple of things I'll tell you about. Immediate. So in training environment, or let's say football. Let's go back to the Reebok check light. When they first issued that to kids and it came on red, that meant that, okay, come off, we're going to check you. Well, I alluded to, I worked with the NCAA. The problem they found out early on was the kids were trying to knock the snot out of the other kids so they could make his red light off. Coach, did I make his light go off? Did I make his light go off? So is that good? Is that bad? In an instruction, if the guy's doing a PLF and he slaps his head on the ground and it becomes red, that's a good thing. You come here. You're going to get retrained. And that's that Army voice. You come here. And they take them over the side and they retrain them again. Downloadable. And the other thing is, sometimes do we want the soldier to know when the light goes off? I'll give you a completely different example, developed over here at Rare. You now know it as Fitbit and whatever. They developed a sleep watch over 40 years ago, okay? But now you're seeing it as the Fitbit and these other devices. So if you could have a device that told you how much sleep you've gotten, is this good or is this bad? and I see the major caught on. So when I briefed this, the Assistant Secretary of the Army, I said, she goes, well, why would that be bad? I said, well, it's 2 o'clock in the morning. You look at your watch. If I go to sleep now, I can get 4 hours of sleep. When you look at your watch at 3 o'clock in the morning, okay, maybe if I fall asleep now, I can get 3 hours of sleep. She said, stop it, Chessley. That's what you just described last night. I don't want to hear it again. And so when is it good to the soldier to know, and when is it not to know? Or when does the platoon leader need to know, or when does the medic need to know? Logistics, and that's just good old-fashioned support. So, now that I said my experience was growing, I now have, beside Fort Benning, I have Fort Bragg, I have Fort Sill, I have Camp Lejeune, I have Eglin Air Force Base, and Joint Base Lewis McChord. That would be called a multi-center trial, for those of you who keep up with how we do multi-center things in medicine, and that's what that is. The reason I've got the names in here is whenever you tell you've actually contacted them, you actually have to prove that you spoke to somebody and that they agreed to do the work. Here's a system that I would like to talk to you about that we just acquired some of. This is PEO Soldier and Rapid Equipping Force Work. And this is a very nice device. It's a vest, but it has 5 separate gauges on it. And this is the first one that has been fully integrated. And this was based on automotive technology. They used sensors that have been in cars, and they tied them together with wires, so when this sensor goes off, it tells this sensor when to read, and it tells this sensor when to read. and it's fully connected, and we just got our first data back from that, and it looks very promising. So as I said, a lot of this technology is in its infancy, and this is the predecessor to what of the future is the ISSS, which is the Individual Soldier Sensor Suite or System. And not only will it have blast and acceleration, but it also it will check the hydration status of the soldier, physiological status. It will give pulse oximetry, the whole 9 yards. And all of that is I actually saw the first full prototype the other day. Medical and human use. One of the things that I've got to promise both the commanders, and it's my responsibility as a medical guy, is safety is always first, and making sure good clinical practice guidelines are there. And that comes back to when the Surgeon General's office asked me to make sure we were doing the right thing and were we doing it properly. So now back to my original job that I got when I moved back to MRMC, and I'm finally now getting to do that. So the science and technology objective, I call it recapturing the initiative. That's a really cool Army term saying I get to do what I said I was going to do the other day, but you wouldn't let me do it till now. So I'm recapturing the initiative. And the Maneuver Battle Lab is those nice folks I talked about at Fort Benning, Georgia. And we briefed Mr. Sandow, who's their SES, their senior civilian at that school, back in June of 2013, and they agreed to support us. Now, the purpose of the STOW was to demonstrate technologies that we could push across the 6364 line, both for medics and for the line, and insert them in a military relevant environment. They do things in the field, and that's how we do it. I'm going to go ahead and say something I'm very, very proud of. Our effort got 2 devices FDA cleared last fall. And the fact that I can say that in my career, that I've done that, is amazing. We're hoping to get our 3rd device FDA cleared this spring. It's a team effort, and it's not just me, but this is a result from some of the work that we've been doing. And so we're very pleased that some of those devices that got FDA clearance have moved to the top of the line to be the first to be done in the science and technology objective. So I have to be proud about that. And this was our original problem statement. This is what I briefed General Corelli on in 2011. He approved it, he blessed it, and made it real, but I had to do all these different things. Identify tools that aid in accurately and objectively assessing soldier behavior and neurological functioning. Early in the war, there was a certain period of the war, it was safer to be in combat than it was be medically evacuated. Because of RPGs and certain conditions on the battlefield, if you were fighting, you were safer. And so the numbers of evacuations, this just immediately blew up a red flag to the Army that we've got to figure out how to only evacuate those soldiers who need to be evacuated and keep those in the fight that we need to keep in the fight. And that was the driver for this. This was my OV1 that I drew when I first gave this, and this is what we had where we promised our medical technologies. So this is prevention. What can we tell the soldiers? We try to do training now to help them be prepared for some of the stressors of war. So psychological testing, psychological training, psychological working with the soldiers to help them understand the things that they will encounter and how to deal with it. But also, we're now looking at nutraceuticals. Are there certain things foods that we can eat that will protect your brain from traumatic brain injury? Then we look at the stressor, be it a blast or be it a very traumatic event that they see, and they see something happen right before their eyes. And so one of the things that you look about this is the impact on the mission, the soldiers' impact. The soldiers will do the mission as best they can, as long as they can, and they will strive to get it done. However, we do know after a period of time, it's fatigue. I don't have the reference with me, but in 1947, there was an excellent paper written by the United States Army Medical Corps about shelling and shell fatigue, which is what we now know as PTSD. And the very first paragraph in the article, it apologizes because they lost 140 data points because the Nazis overran them there at the Battle of the Bulge. They describe each of their descriptions of the different battle sequences is historical in nature. The shelling in Sicily and in Italy, 88 shells, describing the number of guys that shelling for 3 straight days from artillery, and talking about these things. So when you see it, it sounds like just what our soldiers have been going through the past several years. So each of the green boxes is basically where we promised to deliver medical technologies, and this is where we promised to give it to the soldier and the leader. Mission decision tools. One of the devices that we have donated here to the museum is a smooth pursuit eye tracking. It's a red dot. This is not a medical device, it's performance. Let me explain this to you. We do know that certain neurocognitive deficiencies decrease the soldier's ability to follow this red dot, or any of us. We know that several different things can do that. But I would offer to you that if a soldier cannot follow the red dot, there's a good chance he can't aim his weapon. So that's a performance metric. Now, we know other things like fatigue, alcohol, other things impair smooth pursuit eye track. But in this particular situation, I know my situation. And if this soldier, we take him back and he can't follow, you probably need to go lay in your cot for a while. We're going to let you have a little bit of time off because we know that they just came from an incident. And so this is the programmatic thing when I had to explain. I basically just had $275 million to spend over 4 years, and I spent it. This is the brain scope. This is something we have to use to do in a lead room. And this is one of their first prototype got FDA clearance. It's qualitative EEG, electroencephalogram, where they can put the things on and see if the brain waves are normal. FDA clearance. I paid for that prototype right there. And they're going for FDA clearance as we speak. That's our third thing that we hope to get cleared. Here's the sleep actigraph developed by Rare. This is the real one right here. As I said, if you look over there now, we've had a requirement for, like I was telling you about the physiological status monitor since 1989. But there are certain requirements and things you can't do on the battlefield. So when you see these things that you can buy, there's this very prestigious magazine that sells them now. It's called the Sky Mall. It's in the back of the airplane seats. We had that technology 20 years ago, but they wouldn't let us use it. So we've been able to do this for a while. This device is the iTrack. This is one of the early prototypes. You'll see another the prototypes. This is what I want to give you a progression of what something went. So here was their first headborne. Here is this. And for those of you who are gamers, you all know what the Oculus is. They went into agreement. I had to call my youngest son, who's a gamer, to explain to me what it was and how it worked. And they've come into agreement. The SyncThink is working with the Oculus Rift now. And so they went from a standalone that was about 10 pounds to this device, which is 4 pounds, to now that's a device that's 3/4 pounds and can be run on a handheld. And with that, I have to say with sadness, this is my wife's and I black lab we lost 2 weeks ago to cancer, and that is Sam. And Sam was as I got to remind you, I'm originally a veterinarian. How I got here, I have no clue. But I was standing in the wrong place at the wrong time. But I want to thank you for your attention, and with that,